In this video, you will see Julian and Alyssa watching a video of a cow being shot out of a cannon and trying to graph the cow's height off the ground as a function of its total distance traveled. I'll play the animation now. As they work on the problem, consider the understandings they express and determine if their reasoning is valid.
I'm thinking that, so if we have, I'm going to say, this is the starting point, this is the peak, and we'll go like about here-ish, is where the parachute hits. Like, I'm thinking like if we watch it, like goes up, slows down, and then goes all the way down, slows down because of the parachute, so then you're going to have something along the line. Like that, where like you go up, you start slowing down at the peak, and you come down, and then right when you get to like about here-ish, when the parachute goes off, you start slowing down again.
So, like, I see what you're saying, but you keep like mentioning like the speed about it. Like you say, it's like slowing down, but we're graphing height and total distance, and neither of those measurements like have anything to do with time or speed.
I see what you're saying.
So I think that like yes, he's like the cow is slowing down when it the parachute goes off, but like the how much our total distance change, even if it's like a less amount, like a lower amount than before, like the total distance change, well, however much it's changing, that is still going to be equal to the change in the height. So I think that, and like the same with up here is that like from, like say this is height 0 and this is height 1, our total distance traveled is going to be equal to our height at like, well, height 0 plus whatever we go up to. So like if this is our height 0, this is our height 1, I think this is like, because you kind of have a curve here, I think the graph should be more like linear. And then even after here, I think it should continue
To follow the path.
Yeah.
I guess what I'm having like an issue with is the fact that, so you have like this like very, I'll just like draw this thing here, which just like makes me wonder, like, is it a sharp change in like direction? Because like you are stopping at the top here. So like you're going up, and then there's like a moment where you like kind of stop, and then you come back down. So like it is very round. So like I agree. Like I think I see what you're saying with like that, like with this point here, like this portion of the parachute portion, we'll call it. So like this section here, I do see like no. I think it's more this. But this part I'm not sure I'm really understanding, because there is kind of a here slow there.
Like it's okay with this graph since it's just like that's just the point that we are changing direction. So we go immediately from increasing and then we're stopped, so we're not moving and our height's not changing, but then we start to decrease, but then we're also still increasing our total distance. So that's why it comes to such a sharp point, because at that point it stops moving from one direction and changes.
In this video, Julian and Alyssa came up with several candidates for the graph that seemed reasonable. We'll explore how to construct this graph in upcoming videos.